All right, let's get started. So we're going to be talking about elimination. So last time we talked about doing elimination by adding and subtracting. Now we're going to be solving elimination using multiplying. And so the additional step is that we need to decide what variable we want to eliminate, but then we have to multiply by a constant so that when we do add and subtract, it will cancel. And then we'll solve using elimination, which is what we did on page 21. So we're going to go ahead and jump into this example. If I look at this one, example 1, I got 3x minus 8 equals 7. Let's just zoom in a little bit. Ooh, that zoomed in a lot. All right, and then I have 2x minus 2y equals negative 10. So again, I want to try to identify which variable would be easiest to eliminate. So notice that 3 and 2 are the coefficients of x. They don't have a least common, like a number that they both multiply into that's small. So like if I multiply 3 by 2, I'll get 6. If I multiply 2 by 3, I get x 6. But I have to multiply both equations. So I'm really looking on something that I can just multiply one equation. So then looking over here for y, notice I have negative 8 and negative 2. Well, I know that 4 times 2 is 8. This would be the easiest one to eliminate because I only have to multiply this equation by 4. So that's what I'm going to do. I'm going to start out by just multiplying this entire equation by 4. So like basically we're doing a mega distributive property. That makes sense. So I'm going to multiply 4 to the 2x, 4 to the negative 2y, and 4 to the negative 10. And when I do that, I still end up with 3x minus 8y equals 7. And that's going to be on the top. And I'm actually going to change that to black so you know that I didn't actually. Ooh, that's not what I wanted to do. Okay. There we go. Someday I'll figure it out. There we go. All right. And then on this equation right here, now because I multiplied by 4, it's going to be 4x minus 4y equals negative 40. Because again, I'm just multiplying everything by 4. And then now, oops, sorry, that's supposed to be an 8. And so is that. So obviously I can't multiply very well. There we go. Now it looks like it would be. So I'm going to just subtract these two equations because remember negative, I want these to cancel. So if I subtract, their signs will disappear. So I'm going to subtract 8x from 3x. When I do that, I end up, so 3x minus 8x is negative 5x. My y's cancel, and 7 minus negative 40. Oops. So 7 plus 40 is going to be 47. So I have negative 5x equals 47. That is a terrible equation. All right, so then I got to divide both sides by negative 5, and I get x. X is equal to negative 47 over 5. This is terrible, 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 terrible number. Did I mess up somewhere? Nope. That's for reals. For realsies. All right. I guess we're going for it. Dang. That's going to suck. All right. So then now I got to plug it into another equation and solve for y. So I'm going to go ahead and plug it into 2x minus 2y just because I'm dealing with smaller numbers and I like smaller numbers better. So I'm going to go ahead and do that. So if I plug it in using substitution, I'm going to have 2. Notice I'm plugging into the original one. I'm going to have 2 times negative 47 over 5 minus 2y equals negative 10. And when I multiply the 2 and the negative 47 together, I'm going to end up with negative 94. So I'm going to have negative 94 over 5 minus 2y equals negative 10. Negative 94 minus 5 minus 2y. Well, I'm going to add the 94 over 5 over to the negative 10, which is 10 is going to be 40. So let's do that math. I'm going to have negative 2y equals, well, negative 10, if I get the common denominator, is just negative 50 over 5, right? Negative 50 over 5. And then because I added the 94, I'm going to do plus 94 over 5. And so when I do that, I'm going to end up with negative 2y equals, well, when I add those two fractions together, it's really 94 minus 50, which is 44. So I have 44 over 5. And then now I have to divide by negative 2, which remember is the same thing as multiplying by negative 1/2. So divide by 2, divide by negative 2, and then I get y, we'll put this in red, y is equal to, when I multiply by half, I'm going to have negative 44 over 10, which reduces to, I'm sorry, my brain's blacking out, but it's going to be negative 22 over 5. And then my answer is this lovely coordinate that we've gotten, which is not my intention to have this fraction, so I must have done something wrong, obviously. From negative 47 over 5, and then negative 22 over 5. So that is the point at which these two lines will intersect. Sorry about that. That's hopefully the next one's not as cringy as this one is. All right, next example, same thing. I want to find out what variable I can cancel by using multiplication. So notice I got negative 3x and 4x. Those are close. And then I got 2 and negative 13. So because I don't want to multiply by 13, I'm actually going to multiply this equation this time by negative 3, and this equation, actually I'm just going to multiply by 3 and then this one by 4, so that way I can do my adding. So I can add this time instead of subtracting. So let's go ahead and do that. Again, I'm multiplying this equation by 4. I'm going to multiply this equation by 3. And notice that I didn't choose the negative 3 because I don't want to subtract this time. This time I actually do want to add, just because adding is a little bit cleaner. Okay, and so then once I do that math, I end up with negative 12x plus 8y equals 16, because I multiplied everything by 4. We'll change that text to that purple color. Here, we'll change this text to blue. And then I'm going to have that over and then this time I'm multiplying by 3, so I'm going to have 12x. 3 times 13 is 39, so minus 39y equals 15, because 3 times 5 is 15. All right, and then so now I can just add my two equations together, and when I add them, oops, I'm the wrong tool. But when I add them, my x's cancel. Negative 39 plus 8 is going to be negative 31. And this one's much nicer because you'll notice that we'll also get, when we add the x's, the numbers, I have some, sorry for that. The y's, I get negative 31y, but then 16 plus 15 is 31, which means if I divide by negative 31, I'm going to end up that y, in this case, is going to equal to negative 1. So this is definitely a much better problem than the first one. So hopefully you'll never have to do anything as insane as the first problem we did, but this one's definitely going to be a lot better. So then last step, I'm just going to plug it into equation and solve. The first equation, again, I'm just going with it because it's got smaller numbers, but you can choose any one. And just remember that you are going to try to use the original equation. So this time I'm going to go back to not the negative 12x plus 8y, but the negative 3x plus 2y. So negative 3x, we said y was negative 1, so plus 2 times negative 1 equals 4. I do that math, I get negative 3x. Oops, I ended with brackets somehow. Negative 3x minus 2 equals 4. I'm going to add 2 to both sides. I get negative 3x equals 6. Divide by negative 2, and we're going to get, negative 3, and we're going to get x is equal to negative 2. And then my solution for this one is the nice, lovely little point, negative 2, negative 1. So you can see that we can still do elimination even if they don't have the same variables. We just got to do a little bit of multiplication to get there first. And so really, when you're looking at your problems, you're going to want to decide, is substitution better or is elimination better? And sometimes, even if you have to do that one extra step in elimination, it's not the end of the world.